In this video, we're going to discuss the determinants of a 2 by 2 matrix where we use the definition of determinants that involves permutations. So recall, for any time when we're evaluating the determinants, we need to start with a square matrix. In this case, the dimensions of the matrix are governed by 2 rows and 2 columns. And we're going to go ahead and delineate each of the entries in general. We recall from the last video that the determinant definition using permutations is the sum over all permutations in the symmetric group on 2 elements, where we take the sign of the permutation and we multiply by the individual coefficients with some special conditions on the row and column index. In this video, we're really going to discuss what is S2. S2 is the set of all bijections going from the set of 2 elements into the set of 2 elements with the condition that pi is bijective. We call this the symmetric group with 2 elements. This is the symmetric group acting on a set with 2 elements. Each pi, when we say that pi is bijective, it means 1, pi is 1 to 1, which means if the output of 2 evaluations are equal, then the inputs must also be equal. And the second thing it means is pi is onto. And this means the codomain of pi is equal to the range. Everything in the codomain is also in the range. All right. So let's go ahead and look at each one of these. We'll start with what we call the identity permutation. And we're going to call this pi 1. There are 2 ways we're going to define this. We're going to use either function notation or Cauchy 2-line notation. Okay. Function notation requires that for each input, for each element of 1, 2, we say what the corresponding output is. In the identity permutation, we maintain the same value. So if I put in a 1, I get out a 1. For pi 1 of 2, here my input value is 2, and we get out a 2. So in other words, the identity permutation, which we're going to call pi 1, inputs a 1, puts out a 1, inputs a 2, outputs a 2. In 2-line notation, we put the inputs on the first line. So this is all inputs. And right under these inputs, we establish what the output is under this permutation. So for pi 1, the identity permutation, we say that the input of 1 gets an output 1. In this case, we say that the input of 2 gets an output 2. Notice this permutation satisfies our 2 definitions. For each 1 input, there is a unique output. The number 1 shows up in an output only once. The number 2 shows up in an output only once. And all elements of my codomain are also in my range. 2 has a preimage, 1 has a preimage. There is only one other choice for permutations from 1, 2 into 1, 2. And this is what we call a transposition. So pi 2 is a transposition, and it's given as follows. In function notation, we write pi 2 of 1. We can't choose 1 because we've already done that with identity permutation. So the only other choice for pi 2 evaluated at 1 would be 2. Pi 2 evaluated at 2 must then get the element 1. So when we look at pi 2 in two-line notation, we have that 1 gets mapped to 2 and 2 gets mapped to 1. Notice this is a transposition because we're changing one direction. In the next video, we'll talk about how to figure out the signs of each of these permutations. I'll see you there.